Hi. Today we would like to see this coding problem of finding the largest range problem. So in this we have been given a list. This is the list, and we were asked to find the first element and the last element of the largest continuous string, continuous numbers that we can generate from here. Say from this we can write, if you take the number 0, continuous numbers 1, 2, 3, 3, 4, 5, 6, 7. So 7 up to 7 is a continuous. So this is one continuous list we can generate from this. Apart from that, we can, is 8 there in this? No, 8, no. 8, 9, 10 is there, 10, 11, 10, 11, 12. Yeah, that is one list that we can make. And there is no 13, 14, and there is 15. So we have generated these three lists, and the largest list is obviously this 0 to 7, and we just give the starting and ending indices, ending values of the largest list that we can generate. So how to solve this problem? Say for example, we can solve in a way of, like, you can sort this array, just sort uh, this list, sorry, sort the given list, and afterwards you can do looping through these numbers and can find uh, what is the largest string. So basically this sorting itself is taking big O of n log n time, and the calculations will take, maybe if it is taking big O of n time, but the final time complexity would be big O of n log n. So so this is one way of doing, like, sorting and calculation of these largest largest lists, largest length of the lists. That is one way we can do in a much better way. Instead of going with the sorting, which gives a big of n log n. So what we can do is we can go with hashing. Hash. So what hash we can do? So we can initially keep these numbers in a list, in a hash. So in an empty list we will keep all these numbers: 1, 11, 3, 0, 15, 5, 2, 4, 10, 7, 12, 6. So what would be the value? So what is my thought is, you create a hash, and okay, I will come to the what is the value. So we have initially, we are talking about the logic, right? So initially create a hash with all these values. So we can then check while iterating. So you will start iterating through this given list, and you will check. You will take one while iteration. Hmm, say for example, we have taken the first element in the given input list. We haven't sorted this list. We are going with the hash based logic. So we will check one, and we will check through this hash map, hash table, that is there any number less than 1? The number less than 1 is 0. So we will just check, is 0 present in this? So 0 is present in this. Okay, so we will go further, one more step. We will continuously, like, maybe put in some while loop this thing, because we don't know how many times it will iterate. So we'll just keep this in some while loop. in the logic. And we will check, is minus 1 present? Just one number less than the 0. Is minus 1 present in this? So it's not. So we won't. So this is the starting of this value 0. So we are trying to actually create the lists, actual lists. So okay, so after we have completed the left portion, just go to the right portion. Is greater than any numbers greater than 1. So is 2 present? The 2. So 2 is present. Okay. So is 3 present? 2 plus 1 3. Is 3 also present? 3 plus 1 4. 4 is also present. 4 plus 1 5. The next number 5 is also present. 6 is also present. 7 is also present. So when we check 8, 8 is not present. 8 is not present. So the last number would be 7 for this list. We need to implement that in the actual implementation. So we got one list. Okay, so we will check. 8 is not present. So okay, so this we started with this iteration. There is one for loop, and we taken this and we move to the left and right from here, and we just go to the next element 11. So similarly we will check the left and right. So is 10 present in this? So yes, 10 is present. Is 9 present in this? 9 is not present. So the starting for this new list will be 10. And this 11, so increment by 1 and 12. Is 12 present in this? Yes, 12 is present. Is 13 in this hash table? So 13 is not there, so this is the end. So this is the second list. And is 13 is not there, so this is completed. So we just move to the next element 3. So 3, the number 3 is there. Okay, so is we will take 3. So this is a little bit important. See, this is little bit we need to concentrate here. So 3 is there. And so similarly as you go, we check that is there any left elements or right elements. Like, is 2 present in this? 2 is there. And 1 present in this? 1. If you observe closely, what we are actually doing here is we are just recreating this list which we already created. If you start like this, if you don't make any, if you don't store whether we have already taken that element in our previous list, what we would be ending up is we will again recreating those already created lists. So to avoid that, we will go with marking this as some, we need to give a key for this hash table. That is okay, we have taken this one into the list. So we can write like any visited, say like visited or true. So that means you have visited that. So we will keep true. Initially we will keep true. When we can do whatever you want to keep it as true or false or anything. If you keep it as true, that means initially we have kept initially all values to true. That is, we haven't visited, so we need to visit. So whenever you visited one element, say for example 1, you mark it into false. So that means you need not to visit that again. So it's already visited, you need not to visit that again. So similarly we will mark this 0 1 2 3. Similarly, all these we need to mark those already visited values as 3, and while creating a new list, we will check initially that okay, whether this element has a value of false then we need not to go further digging into or recreating the lists of that. So yeah, this is the hash table. So as we know, this hash table can be accessed it big of one times. Yeah, and we will create a variables that is mm, longest length of the possible list. We need not to one thing, we need not to even store this whole list. We can just store the starting and ending of the lists. Uh, we just store the starting and ending of the list. No need to store the all the list, which will take uh, space. Okay, so we will store the starting and end and the length of the list, so that we can compare with the previous iteration whether we got a larger list or smaller length of the list. So that is the logic. So regarding the time and space complexities, so we are not sorting, so no big O of n log n. So we are just iterating, we are just creating the hash table. So hash table takes big O of n. We are not even storing anything. We are just, this is constant space operations. And regarding the time, we are iterating through the uh, list once through the given input list, and we are storing the hash and checking the left and right, which takes place in less than big O of n. So finally big O of n will be the time complexity for this. So if we had gone with the previous approach of create sorting, it will be of big O of n. So we got now time complexity of big O of, oh sorry, if we had gone with the sorting that and doing some operations, the previous method we talked about, it would cost around big O of n log n time and something. So we have got big O of n here for solving this, and space is big O of n. Okay, so we will try to implement this. Okay, so definition, I am going to implement it in Python. Definition of largest range, which will take the single list, the given array, just one input. And as we talked, we need to create some hash table that we can name it as numbers. I'm creating the hash table or dictionary, whatever. So numbers, so I will create the start, and this is the result, right? So I will call something as uh, longest range. Longest range is equal to, this is an empty list, but actually it will store like this. Actually 0 the start of the list and end of the list. Okay, so the longest range and the length of the longest range, long length the long length of the uh, possible potential longest list. Long length is equal to 0. For number in array, what we need to keep, this is the hash table. So nems of, you put the key as nem and the value as true, and this will create the hash table with all the elements like this: 0, 1, true, 11 true, so on. And we created this. And we need to now iterate through the given input list for number in array, for given input array for number in array. We need to check what we checked here. So 1, we checked that if nums of number is equal to, if it is false, then what we can do, if it is false, so you need not to go with that, so just continue. If it is false, say we can write like, if instead of writing this, if not nums of num, we can write that too. If that is not the case, what we will do, while we started iterating through a number, if it is true initially, if 1 is true, and we started iterating through that number, so initially make it as false, that we have visited it already. So nums of num is equal to false. And what is the current length? So we need to, the current length is equal to 1. So current length, and we see the left and right. The left is equal to whatever the number present, the number minus 1. If 1 is there, we check for 0, num minus 1. And right is 1 plus 1, 2, that is num plus 1. Okay, so we have declared the left and right variables, so just declared, and we will iterate in a while loop. While is this 1 minus 1 0, while left in nums in the given dictionary. So what we do, that if it is present, we will initially make that number as, mark that that number as false. And we increment the current length to be incremented by 1. And after updating the current length, which is previously the previous length we declared as 1, because even if it doesn't, if anything doesn't match, if anything the largest range is not there, even one single element will become the largest range, right? That is the base case. Current length is equal to 1. And after updating the length, we need to check further, that is update the left, still go with the minus 1, decrement that. So this will create the possible, go further to the left and create and find what is the possible potential left value. And similarly, while right, in the similar lines to the left, in similar lines, so update the names of right to equal to false, and update the current length, increment by 1, and increase the right. So we checked the left and rights. So finally, okay, for this iteration, we got the current length as this. So we need to check that if the given current length, we need to check is the current length is greater than the long length. If it is greater, then what we can do, you need to update the long length to be the current length. Long length to be current length. So we got the length here. We need to get this right. So we can, yeah, we need to longest range, update the longest range as longest range is equal to. So one thing, while iteration, say for example, if say one, we calculated one and we checked the zero whether it's present in the uh, given hash table, and we go further to -1. So we will end up, while termination of this while loop, we will end up with a number which is not actually, which is one less than the actual number. So what we need to do, we, that is, you understood, right? So if the answer that need to be sent as 0, while termination of this while loop, it will be ended up with number one less than the -1. That condition will check, that condition will be evaluated as false, and it will be coming out of the while loop. So we need to give the longest range is equal to left plus 1, because it gone one number before, left plus 1. And similarly, when coming out of this right loop, right while loop, we need to decrement by 1, because it will go one number out of the actual answer. So we got the largest range. So just return this largest range, longest range. So yeah, so we have returned this. So what we did, we initially like created the hash table, created the variables like this longest range, the longest length for checking the lengths here. We need to check here while iteration. So we initially created the hash table with all the numbers to be true, and while iterating through the list, we, if we visited one number, we immediately created as false. Before that, even we checked whether we need to go further by checking whether the number in the value is true or false. If it is false, you need not to go further, just go to the next number, go to the next number. And we declared variables like the current length for this iteration, that is used while current length, if current length is greater than long length. So for checking that, we created the current length, and we created the left number and right number. So, and we updated the number if it is found, if the left number is found in the hash table, so make it as false and increment the current length to be incremented by 1, and so still go further by decrementing the left, and similarly right incrementing, and check the current length and longest length. So finally we need to keep this longest range as left plus 1, right -1. So just return that longest range. So this will be executing in time complexity of big O of n, because we are just iterating. Just for iterating, this will run in n times, n loops, and this, from this to this, it will run in big O of n. So time complexity is this, and space complexity, we're creating this hash table. So big O of n, space complexity. Yeah, that's it.